the West.
I haven't done this. And then I have to. Then I go on and I go to filmmakers at 5 days.
So that's a no.
No one's ever seen that.
Manager, okay.
Are you their manager? Are you their manager?
Yeah.
Okay. So I gave you the formula sheet last time, right?
Yeah.
Get that out. Formula sheet? The formula sheet, the AP test gives you? There's more back here if you need one. Am I need one? One over here? This sheet. It's not though. Alright, we're gonna do another test, another process. Do you guys want to do the template first and then an example, or do you want to do an example and then the template? Template first? Okay. That's not the board.
I think it's from the screens and stuff from the plot things. When you turn in the answers, then you start screen cross it out.
Yeah, that's weird. They have to wait 30 seconds to check right now.
Literally. The marker bled through. It does it for you. Every time I watch a video, it's like it's infinite, I swear.
It's not really better. It's a little better.
It's a little better.
It's still there, but. Alright, anyways. We're doing a 2-sample Z interval for proportions. So before we did a that's fine. Before we did a 1-sample Z interval. So when we do 2 samples, we're attempting to find the difference between the two proportions. But I'm going to save you, there's only a couple things that are really different. It's largely the same process with some little tweaks. We're going to write out the context a little differently because it'll save you time later. And it helps you label things. So I'm going to write P1 equals true population proportion of context 1. And then P2 equals true population proportion of context 2. So this might be P1 is the true population proportion of seniors who prefer seniors who are Democrats. And then P2 might be the true population proportion of juniors who are Democrats. And then when we write this sentence now, I can use P1 and P2 going forward instead of writing all those words out over and over again. So I'm going to say we want to estimate and the order doesn't matter, but it matters that you keep it the same the whole time. So I could do P2 minus P1, or I could do P1 minus P2. It doesn't make a difference. You could do one, I could do the other, they're both right. But you can't switch back and forth like within the same problem. So we want to estimate P1 minus P2 at a blank percent confident level. But if you want to do P2 minus P1, that is totally fine. So let me just talk about that for a second. Someone that did P2, you don't even necessarily have to write this down, but you might want to. Someone that did P2 minus P1 might come out with like negative 0.3 to 0.1, let's say, for their confidence interval. If the person next to them did P1 minus P2, they would come out with negative 0.1, 0.3 as their confidence interval. No. Yeah. And those are the same. And those are both legitimate answers. They're both fine. It just depends which order you subtract them. So if you get to the end and you have this and I have this, that's okay. So the order doesn't matter as long as you keep it the same the whole way you're doing it. Okay, check of conditions is the exact same thing it was before, but now the conditions have to apply to both. You're going to have two samples now. They have to apply to both. So randomness stated or assumed for both. Sample less than 10% of population, which is that n is less than 0.1 times n for both. At least 10 successes and failures, what's like the math way to show that? What do we write to verify that there's at least 10 successes and failures? That's the NP and NQ thing. So NP is greater than equal to 10, and Q is greater than equal to 10 for both. So you actually have to check 4 things now, because there's NP and NQ for 2 separate samples. And then remember this general starting point, statistic plus or minus critical value times standard deviation of statistic. That's how you start all of these. So statistic plus or minus critical value times standard deviation of statistic. So we're writing the formula out in words, then we're going to write the formula out in symbols, then we're going to write the formula out in numbers, and then we're going to do the math. So the statistic now is different. It's not just like one value. What we're trying to estimate is not P1 or P. We're trying to estimate whatever you wrote up there. So if you wrote P1 minus P2, that's your statistic. Except it's got to have a hat on it now because it came from a sample. If you wrote P2 minus P1, that's your statistic. Up here, there's no hat because we're trying to estimate the true population information. Down here, there's a hat because this is going to be data that came from our sample. So remember, the sample has hats on it. The population does not. Plus or minus, critical value is still Z star. And then the standard deviation of the statistic, you're not expected to memorize this. That's what the formula sheet is for. So we've got 2 samples, standard deviation of the statistic, and we're dealing with proportions. So that puts me in this box here. And don't ever use this special case. This one works every single time. This one only works in a special case. So to me, there's absolutely no reason to ever memorize the special or ever use the special case one. So I'm going to use this one every single time. And if you notice, that's just PQ over N, right? Which is what we did before. There's just 2 of them. So it's the same thing. So it's just twice. So, but you got to go P1 Q1 over N1, P2 Q2 over N2, because you're going to have 2 samples now. put numbers in all those spots. So remember the formula with words, symbols, numbers. So this always feels like weird to write out of the template, but number times number divided by number plus number. So just fill it in with numbers. And then you're going to get like something plus or minus something, and you're going to convert that into a confidence interval. San Antonio, right?
Yeah, I just don't have my glasses today.
You know where you should sit that is in the back corner. Yeah. I can't make it that much bigger. Are you okay? Or can you get it from a neighbor or something? And then at the bottom, so on the before I used to say like we want to estimate the true population, whatever, we are 95% confident of the true population difference in the blah 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 context. Well, now that I've labeled P1 and P2, it's a lot shorter. I can just say we are blank percent confident that P1 minus P2 is between blank and blank. And now you have to have context in your answer. So some people are like, wait, there's no context there. But there is, because I labeled P1 with context, and I labeled P2 with context. Does that make sense? So you don't have to, it just saves you it's just less writing if you do it this way.
You still want us to label
Oh yeah, thank you. I do. So this is your point estimate. And this is your margin of error. So let's do one. Let's look at number 1 on the sheet that I gave you. So the random survey of 100 Milan voters. So first of all, you got to start looking at these kind of like a bigger picture. If I'm reading through number 1, we're going to start having to ask ourselves 3 questions. Is it means or proportions? It's proportions, and that's all we've done so far, but that's percentages, right? So that's proportions. Do you have 1 set of data or 2? You have 2. And then the third question, which we haven't gotten quite into yet, but are you trying to answer a yes-no question, or are you trying to estimate something? And it says we're trying to estimate. So that leads us to it. It's a 2-sample proportion interval. So and you can write, like I put 2-sample Z interval for proportions. If you put 2-sample proportion interval, like that's not the greatest English phrasing in the world, but it works. They want to know that you understand that there's 2 sets of data, that you understand that you're working with proportions instead of means, and that you're doing an interval as opposed to a test, which I know we haven't learned tests yet, but that's coming up next chapter. So then I'm going to say P1 equals true population proportion of, and I'm going to make Milan my P1. Milan Republicans. But you can make Saline your P1. That wouldn't be wrong. You're just labeling it differently than I did. And then P2 equals true population proportion of Saline Republicans. And what we want to do is we want to estimate P1 minus P2 at a 95% confidence level. I always do P1 minus P2. It's just easier for me to keep it consistent. So if you want to follow what I'm doing, that's what I'll usually do. P1's the first thing I read, P2's the second thing I read, and then I subtract them in that order. You don't have to do it that way. I'm just telling you what I do. And then we get into the conditions. So it does say random. It doesn't say random for Selene, does it? That's because I typed it. That's the AP test will do better. So we're going to say SRS stated for myelin. Assume for Selene. And then I got a couple different ways I can write out. My job here is to show that 100 is less than 10% of all voters in myelin, and 150 is less than 10% of all the voters in Selene. You can do it like math-wise. You can write it out in sentences. I'll try to show both. So I could say 100 is less than 10% of all myelin voters. This is probably the best way to do it. 150 is less than 10%. And you can put or equal to there, or less than. It's not a big deal. Less than 10% of all Selene voters. Or you could say, like, both samples are less than 10% of each population. And then I'm going to do the NP and NQ thing. So it might be helpful at this point to kind of on here, on the problem, like label what's what. So I called myelin my 1. And in myelin, N is 100, P is 0.55, which makes Q 0.45. And I called Selene my 2, and in there, N is 150, P is 0.6, which makes Q 0.4. Now, that's just me like summarizing the word problem. And then I've got to show that N1 P1 is greater than or equal to 10. N1 Q1 is greater than or equal to 10. N2 P2 is greater than or equal to 10. And N2 Q2. So you got 4 checks there. And it's basically, do you have at least 10 successes and 10 failures in both groups, but you got to show the math. So this is 150 times 0.55, which is, that's going to be, that's 100 times 0.55, sorry, which is 55. 100 times 0.45 equals 45. 150 times 0.6, that's 90. And then 150 times 0.4 is 60. Those are all bigger than 10, so we are good to go forward. Does that make sense what I'm doing? It's the same thing we did with the one sample version. We're just doing it for 2 samples. So then we're going to write the formula in words. So statistic plus or minus critical value times standard deviation of statistic. So when we did a 1 sample, the statistic was just like p hat. But now that we have a 2 sample, it's got to be the subtraction, the difference between your 2 p's. So I'm going to do p1 hat minus p2 hat. If you decide to do 2 minus 1, it's not wrong. You're just going to get kind of the opposite answer of me, which is still fine. What's critical value? Just in general, we're still in the symbols part. Z star. And then the standard deviation of the statistic comes from the formula sheet. So you don't have to memorize it. I think a lot of you probably will end up almost memorizing it because you use it enough, but you got this. plug in your numbers. So what's P1 hat? 0.55. P2 hat is 0.60. Plus or minus. So Z star is your inverse norm of 1.95 divided by 2. That's like 1.96-ish. And then this is 0.55, 0.45 over 100. Because that's my information from the mile. So these two should always match up. And then like these two should always match up. So this is going to be 0.6 times 0.4 over 150. Yeah, then you have some math to do, right? So this is negative 0.05. That's your point estimate. Plus or minus, and I got to figure all that crap out. So you don't even need parentheses. You can go, so I just did, I did this, 0.55 times 0.45 divided by 100, plus 0.6 times 0.4 divided by 150. Got that. And then you can do square root of answer, you know? And then times 1.96. So did you guys get 0.125? And then label that, what's that? That's the margin of error. You can put MOE. And then we're going to make it into a confidence interval. But let me stop. Are we getting 0.125? Okay. So then do negative 0.05 minus 0.125. So negative 0.175. And do negative 0.05 plus 0.125. This would be 0.07. Questions? Should I stop? Slow down. What can I help with? You okay? So the conclusion is we are 95% confident that what? What were we trying to estimate in the first place? Go back to your thesis statement. What were we trying to estimate? Yep, so we're 95% confident that P1 minus 2 is between negative 0.175 and 0.075. Question on that process anywhere? So there's one kind of big multiple choice thing I want to talk about when everyone's done. Some people are still writing, which is cool. I'll wait.
So for our conclusion, we don't have to label P1 and P2.
So that's the nice thing about doing it up here. Like that P1 already contains the context. So I was trying to save you some writing, so you don't have to write it out twice. You can. It's not wrong if you do. It just takes more time. Might get some kind of hand injury from all the writing. Smith, you got a question or you're stretching? Okay, so this is a super common AP question. Someone says, I think there's a significant difference between Milan Republicans and Saline Republicans. Do you agree or disagree with that statement? is it reasonable to assume there's, let me phrase it that way. Is it reasonable to assume there's a difference between myelin and selenium? The answer is actually no. If there were no difference, if there's truly no difference, like say they're both 0.6, and I subtract them and there's truly no difference, what will I get? I'll get 0. Is 0 in this interval? It is. 0's in between there, right? So if 0 is contained in this, then it's reasonable to assume there's really not a difference between them. If you got something like, I'm pretty sure the difference is between 0.4 and 0.6. When I subtract these two proportions, I get something in between there. Now is it reasonable to assume there's a difference between the two groups? Yes, because 0's not in there. That'll make more sense. I don't know if it makes sense now or not, but it will make more sense. People don't usually have trouble with it. It's just weird when you see it the first time. Any other questions on this one here? All right, do number 2. I will do number 2 also. Don't forget the title. So you don't have to do the same like labeling or order that I am, but if you want to, that's what I'm doing. I'll do it in a second.
Shut it down.
You divide 24 by 40.
That's what you were saying. I heard like subtract is like 70 from 40. I was like, what? You know, seconds of sleep.
Alright, sorry. Apparently they just halted the stock market. Like the trading. Oil dropped so fast. You saw that? I've never seen that happen before.
The stocks.
Well, they still exist. They're probably going down, but they still exist. So, did you realize I didn't give you like the P and the Q? You have to divide to get those. Did you need some help getting to that realization?
It was like, why are these numbers so small?
You were talking about like 0.24. What? What's points?
If they were real, I'd do that.
Are they both 0.6?
They would,
Yeah.
Did not mean to do that. That's alright. That's okay. The center of your interval will be 10. It will be 0 then.
So,
You guys get 0.18 for the margin of error? Everybody got that far? Maya? Well, check it. That's what it's on the board for.
okay, so when you... Oh, I see.
Let me finish and I'll come over. I didn't, like, I've scrolled past the top part, so you can see the rest of it. Is that okay? So I've scrolled past the top part so you can see the rest of it. Is that okay?
Yes.
Is it okay if I check this backward?
Yeah. Please, we're all dying.
Yeah, square root. Okay. Yeah. So you're just like rounding it. Is it 0.17?
That's what I got.
Yeah. I think I did it wrong, actually. I didn't, yeah, I totally did. I know what I did. Yeah.
Is that wrong?
No. I'm wrong.
So is the front part of the
Like they shifted around zero.
Yeah. So that's what you should have. So you did, what you did was right. I apologize. That makes me feel bad, like I'm some monster that just criticizes you. That's not.
No, it's just the work I do.
The work is the monster.
There's just a lot of ways that figure it out.
You can't even see the numbers on your phone.
I become good with
You got it. You're getting to know it.
it's become a calculator genius. And we have blank calculators.
If you got this done, that was my goal for today. Is do the template, do an example together, and have you do an example. Tomorrow we'll do another example, and then we'll do multiple choice questions on this stuff. And then if you look at the next test, then we're just going to roll into the next. So then we do confidence intervals with means instead of proportions, which just changes things a little bit, but the same general process. So your next test will be pretty big. Just let you know that.